What's up, math scholars and math haters? This is Mr. W. We are going to keep going with expected value and actually finish expected value today by talking about one very important idea related to expected value, and that's the idea of extrapolation. Essentially, I'll actually pull up the example of the spinner from the very first video here, and I have added something in the corner here. We have the expected value of just one game, 6 1/4 points, and we got that from there being a 1/8 chance that nothing would happen, we wouldn't get or lose points, a 4/8 or 1/2 chance that we would lose 10 points, and a 3/8 chance that we would get 30 points. So the expected value, the probability average of that ended up being that we would gain about 6 1/4 points every time we played the game. But when we talk about an extrapolation, that's essentially asking, what if we did this over and over and over again a certain number of times? And I've asked here the expected points for playing 20 times, and the way to find this is very simple. And once we've found that expected value for the game or whatever situation the problem talks about, and we need to extrapolate it into playing 20 times or 100 times or something like that, all we're going to do is take that expected value and multiply it by the number of times we're playing the game. So if you need this put in words, this is expected value times what are called trials. Trials are just how many times we do something in a mathematical experiment. So now 6 1/4 times 20 is going to get us 125 points. This means that if we expect to get about 6 1/4 points for one game, if we play that game 20 times, we're going to expect to have about 125 points. And I'll bring up another example from a previous video. This is the example of the entrepreneur from the last video where we talked about pay-to-play problems, where we have to spend some money before anything. And if you remember, this entrepreneur made $13, had an expected gain of $13 from every product that they manufactured, given that 1/3 of them were defective and this person would have made no money, and that 2/3 would have been fine and they could have made $30 from them. That's an expected revenue of $20 per product. Subtract the $7 that it takes to manufacture it, and we got $13. So we come over here, and we're trying to find the expected profit if there are 5,000 of these, if this entrepreneur decides to go big and make 5,000 products. Again, all we're going to do is take our expected value, multiply it by the number of trials. So again, I'll write these down. Expected value times trials. And 13 times 5,000 is going to give us 65,000. The expected profit from 5,000 products is going to be $65,000. So now I have two examples to go through where we will actually need to find the expected value and figure out this extrapolation piece. So here's the first example that we'll go through where we need to actually find the absolute value and do the extrapolation all in the same problem. It deals with insurance. Now, if you don't know how insurance works, basically you pay for insurance on something like a car, and you pay, let's say, $1,500 a year, and you basically say to the company, hey, I'm paying you this much money per year so that if something happens, if my car gets into a wreck or something like that, you will pay me back enough money to fix it. And insurance companies keep very careful track of all this. They keep very careful track of how much money they're getting and losing. But here's an example of an insurance company where their average payout for a claim is $6,400, and the probability of a customer filing a claim is 0.01 or 1%. Okay, so this looks like we have a probability and a value to put together already. 0.01 times, and this is negative 6,400, because that's money that they're paying out to customers, which means that the other probability is 0.99. So there's a 99% chance that a customer will just not make a claim, not do anything. And we're seeing that the average yearly premium, so that's the amount that the customer pays for the insurance and the peace of mind that it offers, If the average yearly premium for all customers is $1,500, okay, so that's an amount of money that we're going to have to take into account as well that we'll need to add. We're figuring out how much the company will expect to make if they have 500 customers. All right, so let's go ahead and do this bit of math here. So this is negative 6,400 times 1/100th. That's negative 64. 0.99 times 0 is just 0. So this is negative 64. That is about essentially how much money they're losing per customer from paying out claims. So now we need to go ahead and add back this 1,500, which will give us an average profit that this company will make per customer of $1,436. Now this is for one customer. We're trying to figure out how much they stand to make if they have 500 customers. So we take 1,436, multiply it by 500. 1,436 times 500 equals 718,000. So if this company has 500 customers, they expect to make $718,000 in 1 year, assuming that all these numbers are correct. It's probably different for an actual insurance company, but that's essentially how a problem like this works. And if you'll notice, we actually had to add some money after we'd figured out all the expected values and everything. It's all in the way the problem is worded. In this case, the problem was asking how much will the company expect to make, which means that anything they're paying out is negative, and any money that they're bringing in is positive. That's why we had negative 6,400 and then plus 1,500. So the last example is probably the nerdiest example I've come up with for one of these videos so far, and it comes from Tabletop RPGs. There's one in particular you might be thinking of, but that one in particular I'm guessing has some strict copyright laws attached to it that they will enforce very mercilessly. But if we're playing one of these tabletop RPGs and we're facing an enemy, and our damage to this enemy each turn is 9 plus our roll of a standard number cube, so one of these that has 6 sides, the numbers go from 1 to 6, and we're trying to figure out what we expect our total damage to be over 6 turns. All right, so if we remember, the expected value of just one of these number cubes for one roll was 3.5, which means that our expected value for damage on one roll is 9 plus the expected value for that roll. So 9 plus 3.5 equals 12.5, which means, once again, this is our expected value. We are rolling 6 times for this damage, so that's 6 trials. An expected value of 12.5 times 6 trials brings us to a total of 75 damage that we expect to be dealing to this enemy. Now again, it probably will not come out to exactly 75, but this is just a way of looking at the probabilities and doing the math and figuring out, okay, what's most likely to happen? I'm expecting to get around how much damage total over these 6 turns. So if you've watched all these expected value videos, congratulations. You are entitled to a Frosty from Wendy's. It's not a coupon or anything, just you've done a lot of math, so I figure you've earned something nice. And if you're my student, best of luck on your assignment. If not, best of luck on whatever work you have to do for this.